The fourth question says, three concentric metallic spherical shells of radii r, 2r, 3r are given charges q1, q2, q3 respectively. It is found that the surface charge densities on the outer surfaces of the shells are equal. Then, the ratio of charges given to the shells q1 is to q2 is to q3 is. We need to find the ratio between the charges initially given to these shells. Let's first look at the distribution of charges in this case and how these charges would rearrange. We have three shells, the innermost shell with radius r, the second shell with radius 2r, and the third shell with radius 3r. And they have charges q1, q2, q3 respectively initially on them. We'll begin our study with the innermost shell because the charge distribution on the innermost shell is independent of charges on the outer shells. And that is because of electrostatic shielding. The charges on the outer shells will have no influence or will create no electric field in the region where the innermost shell is placed. So we'll start with the innermost shell. And all the charge on the innermost shell will rest on the outer surface of it, and that will be q1 charge here on the outer surface of the first or innermost shell. Now, the q1 charge on the outer surface of the innermost shell will draw an equal and opposite charge to the inner surface of the second shell. That is by electrostatic induction. So there will be a minus q1 charge here on the inner surface of the second shell. And that rearrangement of charges on the second shell would cause a plus q1 charge to move to the outer surface of that second shell, which already has a q2 amount of charge. So the net charge on the outer surface of the second shell will be plus q1 plus q2. Now, the plus q1 plus q2 charge on the outer surface of the second shell would draw an equal and opposite charge to the inner surface of the third shell. So we'll have a minus q1 plus q2 charge on the inner surface of the third shell, and that would cause a plus q1 plus q2 charge on the outer surface of the third shell, which already has a q3 amount of charge. So we finally know that the outer surface of the third shell will have q1 plus q2 plus q3 amount of charge. Now, electrostatic induction is what causes the rearrangement of charges here. Now, let's look at the outer surfaces of each shell and find out the surface charge densities there. Sigma 1, which is the surface charge density of the outer surface of the first shell or the innermost shell, will be the charge on it, that is q1, divided by the area of that shell, the surface area of the outer surface of the shell, and that will be equal to 4 pi r square. The radius of the shell is r. Now, sigma 2 will be the charge on the outer surface of the second shell, that is here, divided by, that is q1 plus q2, divided by the area, the surface area of the outer surface of that shell, that will be 4 into pi into 2r square, which is 4r square. And then sigma 3, which is the surface charge density of the outer surface of the third shell, will be the charge on it, that is q1 plus q2 plus q3, divided by 4 pi into 3r square. 3r is the radius of that shell. So you have 9r square. Now, let's work on this. We need to find a ratio. q1 is to q2 is to q3. Let's work on that now. We know that it is given in the question that the surface charge densities of all the outer surfaces of all the shells here are equal. In that case, I can say that sigma 1 will be equal to sigma 2, which means q1 divided by 4 pi r square will be equal to q1 plus q2 divided by 4 pi into 4 r square. Now, I can cancel off 4 pi r square from both sides. Then I'll have q1 is equal to q1 plus q2 divided by 4. On rearrangement, this implies 4q1 is equal to Q1 plus Q2. This is Q2 here, which means 3Q1 is equal to Q2. When I rearrange this expression here, I'll get 3Q1 is equal to Q2. So we have a relation between Q1 and Q2. Now let's work on the relation between Q1 and Q3 again. So we'll equate sigma 1 with sigma 3. This expression here with this expression here, because we know that the surface charge densities of all the outer surfaces of all these shells are equal. So we can equate sigma 1 with sigma 3. That will be Q1 divided by 4 pi r square will be equal to Q1 plus Q2 plus Q3 divided by 4 pi 9 r square. When we cancel off 4 pi r square from both sides, we'll have Q1 is equal to Q1 plus Q2 plus Q3 divided by 9, which can be rearranged to 9Q1 is equal to Q1 plus Q2. We've already found out that Q2 is equal to 3Q1, so we'll write that here. For the sake of simplification, 3Q1 instead of Q2 plus Q3. Now we have an equation here which connects Q1 and Q3 exclusively. That is why we replaced Q2 with the corresponding value, that is 3Q1. Now, this on rearrangement will give you 9Q1 minus 4Q1, which is 5Q1 is equal to Q3. Now, so we have Q1, then Q2 and Q3. This ratio is what we are looking for. And we know that Q1, we'll just write it as Q1 itself. Q2 is 3Q1. And then Q3 is 5Q1. So in that case, we can strike off Q1 from all sides. And then we have 1 is to 3 is to 5 is the ratio. Q1 is to Q2 is to Q3. So let's look at the options here, which matches with our solution. The correct option here will be 1 is to 3 is to 5. Q1 is to Q2 is to Q3 is 1 is to 3 is to 5. So option B is the correct one, correct answer.